it's always good to see new presentations about performance improvements and new features in OVS with DPDK. So we're not going to do that. We're going to do something slightly different. Instead, what we wanted to look at was just talk about how we felt the user experience, and the challenges that we've had involved in integrating DPDK into OVS. Okay, so Open vSwitch dates back from 2009 or maybe even further. Ben can tell us later. But DPDK wasn't integrated into OVS until 2014. So at least a 5-year-old application, and then it has to integrate DPDK. And of course, the obvious reasons why you'd want to integrate DPDK is the performance improvements. But the challenge is that OVS was not built for DPDK from the ground up. So it had a lot of infrastructure in place already. So then it makes it even harder then to integrate something like DPDK. Okay, so just a quick kind of overview of challenges. And if you kind of rewind to 2014 with DPDK, so Bruce may live to regret that he said DPDK is greedy. No, he says no. But obviously things like threading, and it has very set models. DPDK wants to own its own data structures. So what we mean by that is it has a very definite representation of what a packet is, like the RTEM buff. Everything gets done in initialization. So back in 2014, there wasn't a hot plug. So you had to have your devices bound before you started vSwitch. We found sometimes there's been inconsistencies in PMDs. That said, it's really nice to have a PMD interface and be able to wrap things like rings and vhost, and that saves a lot of code in Open vSwitch. But sometimes the differences between NICs can leak out through that PMD interface. Debugging, well, I think that's been a challenge all along, because a typical OVS user just wants to use TCP dump. Long-term support issue, so the first LTS was 16.11. So back in 2014, there wasn't the opportunity to have bug fixes. And I can remember one example where a pretty big bug fix came into DPDK. It was merged into master pretty quickly, but OVS had to wait maybe 3 months before it picked up that bug fix. Okay, so just a few things on that list. So in terms of threading, so OVS creates its own control threads and its own threads for control and data path functionality. So it doesn't use the DPDK slave L cores, but of course we still have to pass in the -c argument if we want to initialize DPDK. And that caused some problems, but eventually we were able to find a way where we could use the one of the CPU set of the OVS control threads to initialize DPDK, and then we'll just kind of go back to normal Open vSwitch control threads that we can schedule with Linux across different cores. So we kept after a while we were able to get back the OVS control thread functionality, and then there was also additional threads added for the data path. So I guess the point is, if you're integrating into an application, you don't necessarily need to stick to the DPDK threading model. You may be able to integrate it with an existing model. Okay, so packets. So OVS has its concept of a packet, and that's a DP packet. So obviously then there's a clash because DPDK has the RTEM buff, and potentially that could have been an issue, but as it happens, luckily DP packet was very well layered, and I guess I'm saying luckily, but I'm probably 100% sure that it was done intentionally and just well-designed code. But that meant that we could have a build option for DPDK, and we could back the OVS DPDK packets with the RTEM buffs. And it's very well confined in one file, so there's just different accessor functions depending on what the back to the DP packet is. And it's probably one of the very few places in OVS that there's any hash define about DPDK. Okay, so initialization. So DPDK initialization requires arguments, and lots of them, we know that. MJ talked earlier on about the minus N4, and I guess to a DPDK user, you could see the way MJ described it, that DPDK users have a hard time to be able to figure out that command line, especially things like how many memory channels do I have. So then you take it one level above, and you've got the users of DPDK, so maybe some of the developers of Open vSwitch with DPDK, but then you've got the users of OVS. So it's way too low level, but we still have to pass them in because EAL init needs arguments. So that was one problem. Another thing was it had to be done when the vSwitch-D was initialized. So Aaron actually submitted patches and made changes for that, and we used the OVSDB to capture those parameters. So even though it might look similarly complex to an OVS user, this is a more standard way of putting parameters into OVSDB. And then they can run vSwitch-D the way they would have done previously. And of course, then with defaults, none of these things actually need to be set. The only thing that needs to be set is that DPDK equals true. Okay, so we can go back to a normal vSwitch-D command line. Okay, so in configuration, so again, devices still need to be bound, and people can use DPDK dev bind, or driver control was introduced as well. So there was no hot plug back then, so DPDK devices had to be bound before vSwitch-D started. And then hot plug came along, so that was a very good addition. Something that seems like a small thing, but in terms of the actual name and the syntax to add a port, there was a very hard restriction on the naming. So it had to be DPDK and then the port number. And there was, you would see numerous mails on the mailing list, about people confused about the port number. And when we were trying to get DPDK, I suppose, or remove the experimental tag on DPDK and OVS, this was a big stumbling block because it was felt that it was a bad user experience that people had to do this. So there was patches submitted, and that was changed to use the PCI address. So that way we could have an arbitrary name for the ports, just like you would normally in OVS, and the PCI could be used. There's a few problems with that we're trying to figure out, because multiple devices can be behind one PCI, so we need some more generic, usable way, but that's something I think we're looking at.
Thanks. So, yeah, one of the issues that we actually still struggle with, so we say here PMDs are used for I/O with hardware. That's good, and we're able to interface with the PMD library, no problem. One of the ongoing issues that we kind of struggle with is there can be integration issues with new NICs. So vendors will come with their PMD, say, hey, look, you can support our NIC, and they'll just use test PMD to run their NIC. We've seen actually first bring-ups of NICs, new NICs, cause seg faults in vSwitch-D because either arguments weren't planned for, or order of operations they didn't expect, or lots of different problems there. And additionally, the reports that come back from those are inconsistent, meaning what the user sees. So the user might see one NIC reporting some number of queues when the queues are enabled, disabled, and another NIC might report, well, we have 100 queues, and so that's all we're going to report, and it's up to the software to change that config. So there's some inconsistencies, not just in the user experience, but also in the first bring up. And so the big point that we wanted to say was you can't assume that there will be zero integration effort just because something runs with test PMD. It's not going to be golden. So now we get to debug. Debug is very difficult to go through when DPDK side goes wrong. There's not much available for debugging unless you actually do get a seg fault, and then you have a core dump, and you have lots of great information to sift through. Otherwise, you have nothing. There are sparse logs that DPDK provides, and kind of what's worse is you have to recompile to enable the logs, which means customers won't ever do that, and users won't ever do that. And if like as a Red Hatter, I have to provide a new RPM every single time I want to like get deeper in debugging, that's really not friendly, and it's difficult to support. Whenever new features come along, applications need to actively enable them, and that goes especially for debugging. So if some new debug framework comes in, or like pdump, for example, the application has to adjust to enable that. That's kind of a pain point for integration. And then we've seen failures that sometimes they're difficult to reproduce because you have all these threads running in concert, you have a lot of work queues being drained by different parts of the system, and it's difficult when that causes a problem to actually debug it, to reproduce it, to make it be reliable. And we're speaking here from a developer standpoint, so if it's difficult for us, I mean, just imagine how difficult it is for users. It's like impossible. Tuning, parameters, figuring out how to get around, maybe like hardware issue, firmware issue, whatever, requires a lot of specialized knowledge, and there's not much documentation that exists for that. So, but I didn't want to leave you with something that was all dark and gloomy. Like, we use the LTS, and Yunhan and Luca doing really good job. Huge amounts of bug fixes backported to 16.11. So that's really nice. I hope that continues. All right, so upgrades. Yeah, we've had a lot of discussion about API, ABI. It prevents dynamic linking, and that means that we need to carry actually multiple versions of DPDK. Every single package that we want to provide, like if we want to provide a MoonGen package, a T-Rex package, an OVS package, they'll all have to have their own version of DPDK linked in. Plus, we'll have to carry the standalone DPDK package for anyone that's doing app development and all that. So, OVS developers are very kind of clued into DPDK, but that's not a guarantee that other apps will be. And we're trying to say like they should be. You really kind of have to follow the development. And I just wanted to point out that so there's a link to a mail on the mailing list from the very first discussions of integrating DPDK, where it was brought up that API, ABI are going to be issues, and hopefully they'll settle out and there'll be a stable ABI. I guess in 3 years we haven't seen that yet, but I'm hopeful maybe it's coming. So, questions?
Okay, thanks, Kevin and Aaron. Thank you.